Element 47, that's silver. Check your periodic table. This is Norris Teaches Science with me, Mr. Norris. This is a Physical Science Edition video. Um, this is a video that follows the physics side of physical science. Hopefully you've watched some of the other wave videos, especially the video on wave parts, because we're going to talk about how wave parts have relationships. So at the end of this video, you should be able to say, I can explain the relationships between the different wave parts. So let's talk about the first one, frequency and energy relationships. So if you remember, I'm going to draw a wave. It's going to be our basic wave. Frequency on these transverse waves is how many top and bottom pairs you have. This one has 2, so this is 2 hertz. What we know is as frequency increases, energy of the wave increases, and also the reverse. As energy in the wave increases, frequency increases. They do the same thing. So this is our standard wave that we're going to talk about. If this wave was given more energy, or you would see a higher frequency. All right. Same thing is that if there's more frequency there, there's more energy. The next relationship is frequency and wavelength. So let's draw a standard wave. It has 2 hertz. I remember in this transverse wave, from one crest to another crest, or from one trough to another trough, is wavelength. If you increase the frequency, you're going to decrease the wavelength. So I'm going to draw the same line length, but we're going to increase frequency. We're going to increase it from 2 to 4. That's 2, that's 3, that's 4. The distance between one crest to another crest got smaller from the original wave. That's because these two do the opposite. So if you decrease your wavelength, you increase your frequency. Same thing works. If you increase your wavelength, you decrease your frequency. They are opposite relationships. All right, wavelength and energy in a wave. So let's have our standard wave. All right. If you increase the wavelength, you will decrease the energy. So kind of makes sense. So we're going to increase our wavelength. There's more wavelength between a crest to another crest. I'm not good at drawing these waves. Compared to right here, that means this wave, the second wave I drew, has less energy than the first wave. They do opposites. Okay, altitude and energy relationship. So let's get our standard wave. All right, if you don't remember, amplitude is from crest to resting position, or from resting position to trough. As energy is added to the wave, the height of the wave, the amplitude of the wave will increase. So we're going to take this same wave, we're going to give it more energy, try and keep the frequency the same. But what would happen is that the amplitude would increase, right? So that would be the relationship here. They do the same thing. So the last relationship is frequency and period. Now, what is a period? Is the amount of time it takes for one wavelength to pass a point. The relationship here is if you increase your frequency, you decrease your period. Because you're having more waves coming in, it's not going to take that long for a wavelength to pass a point. I can't really draw it out because I can't really show time up here on a PowerPoint. These are the type of relationships you would see with the different wave parts. Now, there's another relationship we're going to talk about. We're going to do a different video. It's about the speed of a wave, but that's a whole new thing with math. But please come back and learn some more, and I hope I see you at the next video. This is Mr. Norris. He's signing out.